We usually think of numbers as just tools, right? For counting things, for measuring stuff. But what if that's not the whole story? What if numbers have this secret life that we never see? Today, we're going to put the calculators away and just go play. Let's see what secrets are hiding in there.
I mean, really think about that for a second. What if the numbers all around us are holding on to these incredible secrets, hiding these unexpected patterns, or maybe even a little bit of what feels like actual magic? It's a wild thought, and once you start looking at them that way, math starts to feel totally different.
Yeah, because once you get beyond just basic arithmetic, there's this entire world filled with puzzles and beautiful patterns and behavior that seems almost magical. We're going to do a quick dive into that world, starting with a couple of my favorite examples of what happens when you just start playing around with numbers.
Okay, let's kick things off with something simple and kind of elegant, the palindrome pattern. Now, you probably know about palindromic words, right? Like level or race car. They're the same forwards and backwards. Well, it turns out numbers do the exact same thing.
A palindromic number is just that. It reads the same forwards and backwards. You've got simple ones like 66, you've got more complicated ones like 848, or a classic like 121. They have this really cool, perfect symmetry. But the real fun isn't just finding them, it's realizing you can make them with a really simple trick.
It's called the reverse and add method, and it is just as simple as it sounds. So you pick a number, let's go with 54. Step 2, you just reverse the digits, so you get 45. Now you just add them together, and bam, 99, a perfect palindrome. It's actually amazing how often this works out. For most numbers, if you just keep doing this, you'll eventually land on a palindrome. It's a neat little piece of number magic you can try with pretty much any number.
All right, so that was a fun little pattern, but now we're going to level up. We're moving from a neat pattern to something that feels like a legitimate magic trick. Seriously, this next thing is so consistent, it's almost spooky.
So get this. Back in 1949, there was this school teacher in India named D.R. Kaprkar. He wasn't some famous professor at a big university. He was a guy whose favorite hobby was just messing around with numbers. And one day, he stumbled onto something truly extraordinary, something that was hidden in plain sight the whole time.
So here's the procedure. It sounds almost random. You pick any 4-digit number you want. The only rule is that it has to have at least 2 different digits. Then you rearrange those digits to make the biggest number you can and the smallest number you can. You subtract the small one from the big one, and whatever number you end up with, you just do the exact same thing all over again.
Okay, let's watch this thing in action. Let's start with, say, 6382. We rearrange and subtract, and we get a new number, 6264. Okay, so now we take that number and we do it again. The digits shuffle, we subtract, and we get 4176. It feels like we're just bouncing around randomly, right? But watch what happens on this very next step.
We land on 6174. And here is where it gets really weird. If you try to run the process again with 6174, you get 6174. It's locked. It's stuck in a loop. But that has to be a fluke, right? Just a coincidence with the number we started with?
Nope. And this is the magic. It doesn't matter what valid 4-digit number you start with. This process will always lead you to 6174. Always. Usually in 7 steps or less. This isn't a trick. It's a fundamental property of our number system, a hidden constant just waiting to be found by a curious school teacher. So we've seen a fun little pattern, and we've seen a magic trick that actually has a solution. But what about a puzzle that's so simple you could explain it to a 5-year-old, but so deep that not a single mathematician on the planet has been able to solve it?
Say hello to the Collett's conjecture. The rules could not be simpler. You pick any whole number you want. If that number is even, you just divide it by 2. If it's odd, you multiply it by 3 and add 1. That's it. Those are the only 2 rules. You just keep applying them to whatever new number you get. Let's just follow the journey of the number 12. It starts out falling nicely. 12 is even, so it becomes 6. 6 is even, so it becomes 3. But wait, 3 is odd, so we have to use the other rule. Suddenly, it spikes up to 10. Then it falls to 5, which is odd, so it spikes again, all the way to 16. And from there, it just tumbles down. 8, 4, 2, and finally, it lands on 1. And once you hit 1, you're stuck in this tiny little loop. The journey's over.
Now, here's the part that will absolutely break your brain. Every single number that humanity has ever tested, and we've tested numbers with millions of digits, eventually falls down into that 4-2-1 loop. Every single one. Back in 1937, Larthur Kalatz guessed that this must be true for all numbers. But to this day, nobody has been able to prove it. A problem a kid can understand is still one of the deepest unsolved mysteries in all of mathematics.
So, from these simple repeating patterns to hidden constants to these profound unsolved mysteries, it's really clear that numbers are so much more than just tools for calculation. They're a landscape. They are a genuine playground for your mind.
So what's the big takeaway here? Well, first, that numbers are this incredible playground, just waiting for us to jump in and discover something. Second, that following simple, repeated rules, which is basically what computational thinking is, can lead you to uncover amazing things, just like Copracar did. And maybe the most important lesson of all is that the questions that sound the easiest can sometimes hide the deepest mysteries in the universe.
All of this stuff we saw today, the patterns, the magic, the unsolved problems, it all came from just following a few incredibly simple rules. It really makes you wonder, doesn't it? What other incredible secrets are just hiding out there in plain sight, waiting for a curious mind to come along and just start playing?